All right, this video is going to talk about central limit theorem and how to use that theorem to find probabilities for sampling distributions of sample means. So if x is any random variable, continuous random variable that we can maybe know or maybe we don't know what the distribution is, it is true that if you take samples of that distribution of sample size n and find the mean of those samples, then as long as n is greater than 30, the distribution of the sample means will be normally distributed with a mean the same as the population mean and a standard deviation that is smaller than the population standard deviation by a factor of square root of n. This is, again, only true and only known if n, I should use little n here, is greater than or equal to 30. So again, this is done by calculating the means of the samples and then figuring out what the distribution of those sample means would look like, okay, when you're drawing those from a population. Now, the random variable x bar has a different z-score than the one of x because its standard deviation is different. It is smaller. So it's very important that you know whether or not you are talking about a population x or one instance of your population, or if you're talking about the sampling distribution of sample means and figuring out where that mean is in that distribution. So let's look at an example. Length of time in hours it takes an over 40 group of people to play one soccer match is normally distributed with a mean of 2 hours and a standard deviation of 0.5. So I know that the population of x is normally distributed where the mean of that population is 2 and the standard deviation is 0.5. And that's for all soccer games of this over 40 group of people. Suppose that a sample size of n equals 50 is drawn randomly from the population. Well, then that means of these sample means that I am now looking at, x bar is approximately normal with the mean of the sample means centered around 2 and the standard deviation of the sample means has a spread of 0.5 over the square root of 50. Let's go ahead and find what that is. So if you're using like a 4-function calculator, you have to take the square root of 50 first. And then take 0.5 and divide it by that number. And we end up getting 0.071 when we do that. So what's the probability that a sample mean is between these two numbers? Well, I need two z-scores. So I have two sample means. So let's find the z-score for when x bar is 1.8. 1.8 minus 2 divided by, 0.07. 1 is negative 2.82. And then let's find the z-score for 2.3. All right, sample mean of 2.3. How far away is that 0.3 divided by 0.071. It's very far. This is like approximately like 100%. It's going to be like 0.999 something. All right. So a sample mean of 1.8 is almost 3 standard deviations below the mean. Standard deviation, or a mean, excuse me, of 2.3 is 4.23 standard deviations above the mean. If I wanted to find this probability, let's go ahead and go into our chart and find that. All right, so I'm looking for a z-score of negative 2.82. So negative 2.8 over to 2 is 0.0024 over here. And then let's see. Okay, I found this one. This one's a little bit better. Look, 4 is not even on here, right? So like 0.9, let's just call it like 0.999 instead of 100%. So let's call this all the way to here. 0.9999. So I want to find that between probability. It's going to be almost the entire distribution. So 0.9999 minus 0.0024. This probability here is 0.9975.